Page 82.
Yeah.
Pardon me?
It was on the sheet that we had.
Oh, okay.
Yeah. Yeah. What I said.
So if you handed your assignment in this today, you should grab it just for this part. So you can copy that stuff down. So general form has no fractions or decimals, so you have to get rid of the denominators. Okay, so we're gonna see that we can model some real life situations using linear equations. So Brad is enthusiastic about mountain climbing, but he's a quadriplegic, so he uses custom gear to climb this this mountain or this rock face in BC. So it says that he moved at a constant rate and climbed the 660 meter summit in 11 pitches or sections. Each pitch was approximately 60 meters in height. At 5:45 a.m., he started his climb 60 meters below the top of the first pitch. By 5:55, he was 40 meters below the top of the first pitch. So that means that he traveled 20 meters in 10 minutes. That's what it means. So again, he's going to go to a total of 660 meters in 11 different sections. Each section is 60 meters in height. He started at 5:45 a.m. and he was 60 meters below the top of the first pitch. 10 minutes later, at 5:55 a.m., he was 40 meters below the top of the first pitch. So again, that means he climbed 20 meters in 10 minutes. So let's write that down. He went 20 meters in 10 minutes. So if we actually divide that 20 meters over 10 minutes, that is 2 meters per minute. That is his rate of climb. We are told above that he climbed at a constant rate. He moved at a constant rate. We're told that. And that rate we now know is 2 meters every minute. That's the rate of change. That's the slope, because that's what slope tells us. And we know that we can use a line to represent this scenario because he climbs at a constant rate. Okay? So that is the slope of this line segment. It asks us to write an equation that describes Brad's distance d in meters below the top of the first pitch in terms of t minutes past 5:45 a.m. And we want to express that in the form y equals mx plus b. So we've already found m, the slope. M is 2, which would be 2 meters per minute. Our equation in the form y equals mx plus b will be y equals 2x and there's two ways we can write this equation. This would be one way. Okay, he is 60 meters, each pitch, each section is 60 meters long. As time goes by, he's getting closer and closer to the top of that first pitch. So you can write it like this, where you have a positive slope and the y-intercept is negative. After 10 minutes, 2 times 10 is 20. 20 minus 60 is negative 40. That negative 40 would represent that he is still 40 meters away from the top of that first pitch. Or you could also write it as y equals negative 2x plus 60. Again, if you let x equal 10 minutes, Negative 2 times 10 is negative 20. Negative 20 plus 60 is your 40. 40 meters away from the first pitch. Either one would work. Either the slope is negative and the y-intercept is positive, or the slope is positive and the y-intercept is negative. It doesn't matter. One will give you a negative value for how far you are away from the top of the first pitch. One will give you a positive value, but they both mean the same thing. So it doesn't matter. Either one of these works. Now, the only thing you might do differently, you're going to write it in slope-intercept form, but you might change the variables. Instead of y equals, you might say d equals, the distance from the top of the first pitch. And I'm going to use the second equation, the negative 20, x plus 60, but I might change x to t, where t would be the number of minutes. So d would be the distance from the top of the pitch or section, and t would be the number of minutes. So there's our equation. That's our answer for part A. We changed the variables and we've now defined what each one means. Okay. Part B, how long did it take for Brad to reach the top of the first pitch? So there'll be a couple ways we can do this, but I'm going to do it using the equation, right? D is the distance away from the top of the first pitch. So if he's made it to the top of the first pitch, that means D is 0. And we want to know, what does T equal? What value of T will make D equal to 0? So I'll take the equation D equals negative 20T plus 60, and I'll let D equal 0. And now we want to solve for T. So to get T by itself, I'm going to start by adding 20T to both sides. And what that does, it makes our T term positive. So that'll leave us with 20T on the left equaling 60 on the right. And then we would divide both sides by 20. I'm sorry. It's not 20, it's 2. I'm not sure why I wrote 20. For some reason I put 20 when it should have just been 2. So we'll fix that. Apologize for that. So it just should have been 2T plus 60, negative 2T plus 60. So now we're going to add 2T to both sides. And that'll give us 2T on the left equaling 60, and we'll divide both sides by 2. And that'll give us T equals 30 minutes. So that's how long it would take to climb that entire first pitch. And that's how long it'll take to climb all the pitches, because we're told he climbs at a constant rate. It's always 2 meters per minute. Each pitch or each section is 60 meters long, so it's going to take 30 minutes to climb each pitch or each section. So there's part B. Part C, in total, he spent 8.5 hours changing the ropes between pitches. How long would it take Brad to climb the entire rock face? So there are 11 pitches or 11 sections. Our total time here, which is what C is asking us to do, there are 11 sections times 30 minutes per section. So if we multiply those two together, that'll be the entire time in minutes that he's actually climbing. So that'll be 330 minutes, which, if I convert that into hours, there are 60 minutes in every hour. So we divide 330 by 60. That's 5.5 hours. And then we are told above that he takes 8.5 hours, a total of 8.5 hours to change ropes between each pitch. So our total time will be found by adding 8.5 and 5.5 together, which is 14 hours. That's how long it would take him to do that climb. A total of 14 hours. Jan, do you want to grab another booklet from over there instead of writing it down on that? Okay, so again, the reason that we can set up a linear relation for this is because we are told that he climbs at a constant rate. Only lines have a constant slope, and the slope tells you the rate of change. In this case, that rate was 2 meters every minute that we were able to come up with from the information we were given. On the next page, a family drives at a constant speed from Wrigley in the Nunavut Territory to visit relatives in Fort Providence, again in Nunavut. When they start driving at 9 a.m., they are 540 kilometers from Fort Providence. At 12:30, they reach Fort Simpson, which is 225 kilometers from Fort Providence. We want to write an equation that describes their distance d in kilometers from Fort Providence in terms of t hours past 9 a.m. and then determine what time the family will reach Fort Providence. The reason we can write a linear expression for this is because we are told they drive at a constant speed. The rate of change is a constant. And slope tells you the rate of change. In order to have a line, the rate of change must be a constant. And it is. So that's why we can come up with a linear relation for this scenario. So we're going to write the equation. To do that, we need to find the slope, the rate of change, and then we'll also see what our b value will be. So at 9 a.m., they're 540 kilometers from Fort Providence. At 12:30, so that's after 3.5 hours, they will have traveled, and that distance traveled will be found by taking the difference between how far they are from Fort Providence at the start and how far they are at 12:30. When they start their journey, they're 540 kilometers away from Fort Providence, and at 12:30 now they're only 225 kilometers away from Fort Providence. So if we subtract those, that's how far they traveled in 3.5 hours. So they traveled 315 kilometers in 3.5 hours. So to find our slope m, our rate of change, it'll be the distance in kilometers per hour. Okay? Or not distance, but their speed, I should say, in kilometers per hour. So they went 315 kilometers in 3.5 hours. If we take our calculator and actually divide those, 315 divided by 3.5, that'll give us their speed in kilometers per hour. Because it's kilometers on top and hours on the bottom, that's where we get kilometers per hour from. So that is their rate of change. That's their speed. That's m, the slope. And like we did before, because we're always getting closer to their destination of Fort Providence, their slope and their distance away have to have opposite signs. One's got to be positive, one's got to be negative. So if we write this first in y equals mx plus b, it'll be y equals 90x, actually negative 90x plus 540. I'll do this one like I did the last one, where I keep my slope negative, then my distance will be positive. Those two are always working against each other. The more time goes by, the closer you're getting to the destination. However, we probably want to write this equation, though it says in terms of d and t. D, the distance in kilometers away from Fort Providence, would be 90 times t plus 540, where again t is the time in hours. And those are defined above here. D, the distance in kilometers, t, hours, which is the number of hours past 9 a.m. So those two variables are already defined above. And part B wants to know at what time will they reach Fort Providence. Well, that will be when D, the distance, is 0. They are 0 kilometers away from Fort Providence. So now we're going to solve for T. I would probably add the 90T to both sides. That gets our T term by itself, but it also makes it positive. So on the left, we'll have 90T equals. On the right, you're just left with 540. And now if you divide both sides by 90 to get T by itself, I think you'll get 6. It will take 6 hours for the family to reach Fort Providence. Okay? So again, because you're always getting closer to Fort Providence, the slope and the distance, the y-intercept away, have to have opposite signs. That's the only way that that distance will get smaller, or they'll get closer. Okay? Pardon me? So let's do some more practice, and some of this is going to help you on your quiz today, because your quiz is on slope-intercept form. That's one of the things that's on, as well as general form. Okay, so pay attention. This is going to help you on the quiz today. So you've got the slope-intercept form, y equals mx plus b. You've got the general form. Remember, everything on one side equal to 0 on the other. No fractions or decimals, and the x term should be positive. And there's the slope formula that we use if you have 2 points and you want to find the slope. Question 1, express that in slope-intercept form, which means you need to get positive y by itself. And then we can state the slope and the y-intercept. So, start by adding 5y to both sides. You want to get positive y by itself, so by doing this, you're getting the y term by itself, and you're also making it positive, which are two things that we want to do. Okay? So, this will leave us with 4x minus 10 on the left, equaling 5y on the right. And now to get positive y by itself, we would divide everything by 5. All the terms get divided by 5. So that'll give us positive y by itself on one side. The other side, you'll have 4 over 5x minus the second term on the left is 10 over 5, which is 2. Now it's in slope-intercept form. And remember, m, the slope, is the number in front of x. That's 4/5. B, the y-intercept, is negative 2. So there's your slope and your y-intercept. M is the slope. B is the y-intercept, where the graph crosses the y-axis. Number 2, express that in general form. Remember, general form No fractions or decimals. Everything on one side equal to 0 on the other, and the x term should be positive. I'm going to start by getting rid of my denominator by multiplying all three terms by the common denominator, which would be 15. So the y gets multiplied by 15. The negative 2 over 3x gets multiplied by 15. And the 4/5 gets multiplied by 15. And the reason we do this is because you can divide. You can get rid of the denominators. 15 divided by 3 is 5. We've gotten rid of that denominator. 15 divided by 5 is 3. We've gotten rid of that denominator. If you multiply out what's left, we'll have 15y equals negative 2 times 5 is negative 10x plus 4 times 3 is 12. But we're not done because general form has to have everything on one side equals 0 on the other, and the x term must be positive. So because of that, I'm going to add 10x to both sides as well as subtract 12. So over on the left side, we'll have positive 10x, we'll have positive 15y, and then minus 12. So there's our equation in general form. Okay. Number 3 says determine the equation of each line described below, express them in slope-intercept form. So the first one, you're told the slope and the y-intercept. Slope-intercept form is y equals mx plus b, where m is the slope, we're told that's negative 4. B is the y-intercept, which we are told is 3/4. There it is, it's done. There's nothing else you have to do. You can have fractions in slope-intercept form, just not in general form. That one is done. Now for question B, we're given the slope and where the graph crosses the y-axis, but that's the same thing as the y-intercept. The y-intercept is where the graph crosses the y-axis. So again, just like the one above, we can just use y equals mx plus b. The slope is negative 3, so that's m. Our y-intercept is minus 2. So that's your b value. Again, that one is done. You're given the point where it crosses the y-axis, which is what the y-intercept is. So our y-intercept is negative 2, and that is the b value. Now C, you're not given the y-intercept, you're giving another point. You're given the slope, but another point. For this one, I would use point-slope form. Remember, if you got a point, that's x1 and y1, and m, the slope, is 5/6. So y minus y1, which is negative 1, equals m, which is 5/6 bracket, x minus x1, which is negative 9. So the minus minuses become a plus positive. And that would be the equation in point-slope form. But we are asked to write it in slope-intercept form, which is y equals mx plus b. So I need to do that. Probably the easiest thing to do here is to start by multiplying both sides by 6, because that is the denominator on the right. And the reason we would do that is because now those 6's cancel, and you've gotten rid of the denominator. If you multiply out what's left, on the left we'll have 6y plus 6 equals, on the right it's 5 times x plus 9. 5 times x is 5x plus 5 times 9 is 45. We're asked to write this in slope-intercept form, so we need to get y by itself. Subtract 6 from both sides, and you'll get 6y equals 5x plus 39. And then we would divide both sides by 6, and that gives us y by itself. 5/6x plus 39/6 And I would leave it like that, because if you actually divide 39 by 6, well, I guess you could write it as 6.5. It's a terminating decimal, so you could use that. If it's a non-terminating decimal, though, you wouldn't want to write it as a decimal because now you're rounding it, and it's no longer accurate. So you could write that y-intercept as 39 over 6 or 6.5. It doesn't matter. Question D, exact same type of question. You'll use point slope form. So there's x1 and y1. M, the slope is negative 3/4. So it'll be y minus negative 3 equals negative 3/4 bracket x minus 16. Again, the minus minus becomes a plus positive. That is the equation in point slope form, but we want to write it in slope intercept form, which again is y equals mx plus b. What I would do then is multiply everything, both sides, by 4 to get rid of the denominator on the right. And the reason this works is that on the right side, those 4's cancel. 4 divided by 4 is 1. So if you multiply out what's left, you'll have 4y plus 4 times 3 is 12 equals, now it's negative 3 times x, and negative 3 times negative 16 is positive 48. Remember, slope-intercept form means having y by itself, so I'll subtract the 12 from both sides, which will leave us with 4y on the left equaling negative 3x plus 36, and then we will divide both sides by 4. So y equals negative 3 over 4x plus 9. Now it's in slope-intercept form, which remember tells us the slope is negative 3/4, which matches what we have above there. It also tells us the y-intercept. Y-intercept is 9. That's where the graph crosses the y-axis, the point 0, 9. What's different about question E is you're just given 2 points, so we would start this one by using the slope formula. If the first point is point 1, that's x1 and y1. The second point will give us x2 and y2. So it'll be negative 13 minus negative 3 over negative 1 minus negative 6. Again, the minuses both become plus positives. So it'll be negative 3 plus 3, negative 13, plus 3, which is negative 10, over negative 1 plus 6 is positive 5, which is negative 2. That's our slope. That's m. And we did questions like this before. If you use point slope, depending which equation you use, the point slope form will look different. It'll look different depending what point you use. But we also saw, if you do everything correctly, the slope-intercept form will work out to be exactly the same. So it doesn't matter which point we use. I'm going to use the first one. Y minus negative 3 equals m, which we found to be negative 2 bracket x minus negative 6. Again, the minuses become plus positive, so it'll be y plus 3 equals negative 2 times x is negative 2x. This minus becomes a plus positive, so it's actually plus 6 times negative 2, which is minus 12. And then we would subtract 3 from both sides to get y by itself for slope-intercept form. So negative 2x take away 15 is our equation. Which is accurate, and here's how I know. If we take the point negative 1 comma negative 13, so this is like a check, and we apply our slope of negative 2, which remember, slope is rise over run. So rise negative 2 and run 1. So from this point, if you rise negative 2, it means you're going to go down 2. So the negative 13, which is the y value, will be decreased by 2 to negative 15. And the rise is positive 1, so you're going to go up 1. So the negative 1, the x value, I said up 1, I meant to the right 1. The negative 1 x value, if you go to the right 1, it becomes 0. 0 comma negative 15 is the right y-intercept, which is what the equation tells us. So that's a little check that we could do to make sure that our equation is correct. Question F, same thing. We'll start this one by using our slope formula to find out what the slope is. So if the first point is 0.1, that's my x1 and y1. Second point gives me x2 and y2. y2 minus y1 over x2 minus x1. 3 take away 5 is negative 2 over negative 4, which is positive 1/2. There's our slope. And if we use point slope, as we've said, as we saw yesterday, depending on which point you use, this part will look different. If you use 2 comma 5 or negative 2 comma 3, this part will look different. But when you put them in slope-intercept form, they'll be the same. So I'm going to use the first point just because there's no negatives in that one. There's the point slope form. And that part again would look different if you use the other point instead. But if you put it in slope-intercept form from there, they will be the same in the end. And we saw that yesterday. So when you multiply out the brackets on the right, half times x is a half x. Half of negative 2 is minus 1. And then we would add 5 to both sides to get y by itself. Negative 1 plus 5 is positive 4. And so there's the equation. 1/2 x plus 4. So that means your y-intercept is plus 4. And again, we could check that using the point negative 2 comma 3. So if we start with the point negative 2 comma 3, and we use a slope of 1/2. That means you're going to rise 1 and run 2. So if you rise 1, you're going to add 1 to the x value. The y value, gives you 4. If you're going to run 2, you're going to add 2 to the x value, which gives us 0. That confirms that if you start at one of the point you're given, which is negative 2, 3, and you apply a slope of 1/2, which is rising 1 and running 2, you end up at 0 comma 4, which confirms the y-intercept is at 4, which matches what we have in our equation. Okay? All right. So for practice, you can work on page 378 to 379, questions 5, 6, 10A and B. So this will be for practice and what we learned today about writing equations, as well as working with different information to write equations. I will post these solutions to Google Classroom. Remember, the stuff from yesterday is due for marks. That was page 80 and 81, I think. That's due for marks. But now you're going to clear your desk for your quiz. Okay? No, you can keep it.